Hello everyone, my name is Jayesh Mahajan. Today I will introduce about my topic machine learning for research ranking. Now these are the table contents. First of all, introductions, machine learning basics, features engineering, personalization, search ranking, challenges in machine learning for ranking, conclusion and references. First of all, I will introductions. Introduction: the machine learning plays a critical role to improving search and ranking algorithm in various applications such as search engine, e-commerce, content recommendation system. The goal of the using machine learning for search ranking to improve user more relevant and personalization in search result. There are some key aspects of the machine learning of the search ranking. In this presentations, we are explore the fundamental elements, design principle, strategy, empower user means, and expanding C information in case of confidence. Next of the machine learning basics. First of all, I will introduce about what is the machine learning. Machine learning. Machine learning is the study of algorithm, statistical models, computer systems used to perform specific tasks without using explicit instructions, but instead relying the pattern interface. There are the types of machine learning: supervised learning and unsupervised learning. First of all, supervised learning. The models is trained on labeled data and managing the learn to make predictions or decision based on the input and output pairs. This and second with the unsupervised learning. Unsupervised learning involve working with unlabeled data, and the system tries to find structure and relation within the data. Next will be the features engineering. First, there are the goals of the features engineering: content of the search ranking, creating meaningful and relevant features from the available data, and it can help the model understand relations between queries and document. There are the query document similarity, calculate the similarity score between the query, search query, document using like a TF, IDF, cosine similarity and word embedding. Keywords matchings, identifying whether how often query keywords appears in the document in title, body or other relevant sections. And page ranking, assign the importance score to web pages based on their link structure. Next will be the personalization in search ranking. First is the user feeling, and second will be the content recommendation. First of all, the user feeling: create a user profile by collecting data, use behavior, preferences, and demographics. This may include the information such as past query. Content recommendation is a personalization algorithm. Analyze user profile, matching them with contents that is mostly like to the interest. It can include articles, products, videos, or any other relevant contents. The next will be the monitoring and maintenance. It is a part of the users. Monitoring and maintenance. It checks the regular performance and regular performance checks like keep on eye how will the new model is performing over time. Set up your regular evaluation. Ensure it's still effective as a user behavior. Content involved. Data drift detections. Next will be the data drift detections. Also user feedback analysis. Data drift detection is to check the changes in data disruptions. If the characteristics of your input data start to shift, it can affect the module's performance, adjust, retrain if it needed. User feedback analysis is actively seek and analyze user feedback. What are the users saying about the search result? Are common complaints or issues in the real world input is goal for improvement. What is okay next will be the model solution. Linear regression, logistic regression, decision tree, random forest. Linear regression is a simple interpretable model, but it may not capture the complex relationship in the data. Logistic regression is useful to dealing with binary outcomes or relevant or not relevant. It's interpretable and computable efficiency. Decision tree is great for capturing on non-linear relationship and hierarchical in the data. They can prone to overfitting. Random forest, a collection of decision tree that can reduce overfitting and increase robustness and is powerful flexible data. Some feedback loops also. User feedback collection is active to gather feedback from user about a search result. You can use survey, rating, direct user interaction to understand their performance, pain points, feedback analysis also. It is a systematical analysis. The feedback can receive, look for a pattern or a common themes. Are the specific types of the content that a user constantly find use helpful or problematic. Next also the model performance matrix is continuously monitoring the performance of your learning models. Are the drop in accuracy, precision or other relevant metrics? Identify when why this change. In model selection, the linear regression is also the simple interpreter models, but it not be capture the complex relationship in data. Logistic regression is useful when dealing with binary outcomes. It also interpretable and computational efficiency. Decision tree it is great for capture or linear relationship hierarchies in the data. However, they can prone overfitting. Random forest is a collection of decision tree that can reduce overfitting and increase robustness. It is a powerful and flexible model. Feedback loops. Feedback loops also different types: user feedback collection, feedback analysis, model performance matrix. Actively, they gather feedback from the user about the search result. You can survey, rating, direct user interaction, understand their preference, pain points, main points, filter points also. And next with the feedback analysis. This is systematic analysis. The feedback you receive. Look for pattern, common themes. Are the specific types of content that are user consistent, find helpful and problematic. Model performance matrix is a continuously monitoring the performance of machine learning model. Are there drop in the accuracy, precision, other relevant matrices? Identify when there is change. Okay. Next will be the optimization. Optimization is a defined success matrix. Hyperparameter tuning, features engineering. Defined success matrix is clearly defined the matrix that measure the success of your module. That could include the precision, recall, accuracy, other relevant metrics based on your specific goal. It lies just like a specific goal and recall also accuracy. And next with the parameter tuning. It is experiments with different hyperparameters. The might involving adjusting learning rates, regulations, parameters, other setting depending on the algorithm you are using. Next with the techniques like grid search like a column search, random search can be help to find optimization, can be help to find optimal values. Yes, is can be find the accurate value, can be find the accurate value, can be find the max mean values. Next will be features engineering. Refine your features, better representation, underlying patterns, your data might involve creating new features, transforming existing one, or removing irrelevant ones. Next will be challenging in machine learning for the search ranking. First of the main and focus challenge is the data quality and quantity. The availability of the high quality label data for train and evaluation is often challenge. Collecting, maintaining large and diverse data set can be cost and time consuming. Next, data quality and quantity is also main point of the challenging point of the search ranking. In that data quality and quantity, the this which data we can prefer most rating, they can see the upper side of the reviews. It's just like an example. Next will be the data sparacity. Many search ranking tasks suffers from data sparacity, which can make a challenges we can make a challenge for machines learning models to generalize effective. This is a particular true of the long tail queries, rare and user behavior. Mm, Next will be the dynamic user behavior. Dynamic user behavior is like a user preference and behavior evolving over time, adapting this change and keeping the ranking models and up to data consist challenge. Dynamic behavior, like if the data will be structured or unstructured, it can behave as like a structured data or unstructured data. And data quality is also main point of this. Next will be the conclusion. The main challenge in this domain range from the quality and quantity issue. In that optimization point, define metrics and hypertuning and features engineering is also the optimization. Is also include the of conclusion. The challenge in this domain range from data quality and quantity issue to involving natures of the user behavior as well as ethical consideration, privacy concerns, and bias mitigations, balancing personalization with fairness and maintaining user trust vital goals. To address this challenge, ongoing research to, and develop efforts necessary. Search engine recommendation system must be continuously adapted and experimentals involves to meet and dynamic demands, ever-changing landscapes, online content, transparency, fairness, ethical responsibility, integral to build trust with user, ensure that machine learning for search ranking benefits for everyone. Yes, machine learning for the search ranking also using way different and applications like Google search engine, Yahoo, different applications also, others applications like now these are the references I have preferred, Microsoft, Google's, and these are the links I have preferred. Thank you. Thank you. References. Thank you. अच्छा ठीक है ये वाला पॉइंट